Okay, I'd like to run through 3 different examples showing you how to draw shear and moment diagrams. The first one that I'm going to do in this this video is this particular beam configuration. So if we look at this, this is our beam configuration. We have our x and y coordinates already established for us to be at this lower right-hand side, or left-hand side, excuse me. I have no reaction forces that I need to calculate at this point because I'm starting out at this left end. If it was a simply supported beam, I may need to know what those reaction forces are first. You'll see that I have established the coordinate system to be right underneath the current diagram that we have, the free body diagram of this. The first step in solving this problem is to create a cut. So I'm going to cut somewhere between A and C. So this is my, cut 1. And that is, of course, between 0 and L. I can go all the way up to that point. Next, we have to draw the free body diagram. Okay, so let's look at our free body diagram. You will see I have some location of X. I've taken my cut. I have my shear force shown in the positive orientation that I want, my sign convention. I have my M cut. I have put this in here for my axial load, but I know looking at this, if I sum forces in the X direction, that will be 0. So I'm not going to really spend much time with that one. The next step is to do our equations of equilibrium. So if I solve, summing forces in the Y direction should equal 0. I have a minus P minus V cut. My V cut is equal to a minus P. Next, I want to take a moment, and I'm going to take the moment at the cut. That should equal 0. If I look at this, my force P is causing a positive moment. Its moment arm is that distance x. And then I have a plus M cut for my moment. My moment M cut is now equal to a minus Px. If I solve for Px between 0 and L, so at 0, at x equals 0, my M cut equals 0. At x equal to L, my M cut equals a minus PL. So let's take a look at this on our shear and moment diagrams. Okay, so if I am to plot this, we see I will have a negative P value, and that stays constant for all of x, and then we'll come back at L, my length. If I look at my moment, it starts out at 0 and then goes down to a negative PL. And you'll see I don't need to do any more cuts, because anywhere I cut in here, it's going to be the same for this whole diagram. So this is my shear and moment diagram. Just some observations from this. We notice that at the end of a cantilever beam, I don't have any moment. My shear is constant with only one loading, and then we notice this other thing, that my shear is constant, but my moment is linear, right? It has a linear shape to it.